Today's lesson is on the greatest common factor. This, as you remember, is part of our fraction unit. As you may remember from multiplication, factors are numbers that you multiply together to get an answer or product. The greatest common factor is the greatest number that is a factor of two or more numbers. So if we looked at this example, what were the greatest common factors of 6 and 8? Both 6 and 8 are small numbers, so we could talk about the factors of 6 for a minute. Well, I know it's 1 is a factor of 6. I know 2 is a factor of 6. 3 is a factor of 6. And not 4, not 5, but 6 itself. If I look at that for a minute and look at the factors of 8, I know it's 1. 2 is a factor. 3 is not a factor of 8, but 4 is. 5 is not. 6 is not. 7 is not, but 8 is. Helps to know your divisibility rules here. So in looking at these two sets of numbers, the greatest common factor between 6 and 8 is a 2. That's the factors that's in common between both numbers. It's really the only one in this case. So if I erase here to check, yes, in fact, we're right. The greatest common factor is 2. There are several ways to find the GCF between two numbers. The one way we just did, and that you've learned to do before, is to make simply a list of factors. So if we're looking at factors of 12, again, divisibility rules can help you here. I know that the first one is a 2, and these factors always come in pairs. Or the first one is a 1. 1 times 12 is 12. My next number from 1 is 2. Is 2 a factor of 12? Yes. In fact, it's 2 times 6. My next number is 3. Is 3 a factor of 12? Yes. It's 3 times 4. We sometimes call this the rainbow method because, as I said, the factors come in pairs. And if you draw little connections, it sort of looks like a rainbow. I do the same thing for 24. I make a list of the factors of 24. First one always being 1, the last one always being the number itself, 1 and 24, my upside down rainbow. I then say, is 24 divisible by 2? Yes, it's 2 times 12. I ask the same of 3. It's 3 times 8 and 4 times 6. I have a little inverted rainbow there. But those are the factors of 24. I look and ask myself, what factors are in common between both 12 and 24? And I can see, of course, 1 is always a common factor. And then I have 2. I have 3 in common, 4 in common, 6 in common, quite a few here, and 12, in fact, is in common. You'll never have a common factor that is greater than the lowest number of the lowest factor. But in this case, we say the greatest common factor between 12 and 24, the greatest is in fact 12. Let's check, see if that's our answer. Yes, in fact it is. So one way is to do the rainbow method or the listed. Another way to find the GCF between two numbers is to do a factor tree. You may, again, we have the same numbers, 12 and 24. The first thing to ask yourself with a number is, what are two factors that equal that number? Any two factors. Well, in this case, I chose a 3 and a 4. You draw your branches, and I say 3 times 4 equals 12. The next question to ask yourself, can this be branched out any further, or is it prime? You remember that prime numbers are numbers that can only be divided by 1 in itself. So in fact, 3 is prime. I can't go with any further branches. 4 is not. I have another set of 2 branches, and the product of 2 times 2 equals 4, and we both know, or we all know, that 2 are prime. So I look at my prime numbers here, a 3, a 2, and a 2. Those are my final leaves. And I say 2 times 2 times 3 is 12, check. That's a prime factorization of 12. I do the same thing for 24. I choose two factors. In this case, I chose a 4 and a 6. Really could be anything. I could have chose a 3 and an 8, a 2 and a 12. I sort of like 4 and 6 and chose them. I say, are 4 and 6 prime? The answer is no. So I do further branches. 4 can be broken down into 2 times 2. 6 is a 2 times a 3. We all know that 2's and 3's are prime. So my factorization for 24 is 2 times 2 is 4, times 2 is 8, times 3 is 24, check. Now, to discover the GCF, I take the common factors of both the 12 and the 24. In this case, the common factors are 2 2's and a 3. 2 2's and a 3. I put them down here in an equation. 2 times 2 is 4, times 3 is 12. 12 was my GCF, which you'll remember from the listing method as well. The GCF is always going to be the same between two numbers. It doesn't change depending on what method you use. Now we're going to look at one more way to find the GCF. You remember watching Miss Rebecca in the YouTube video, and she calls this the birthday cake factorization method. So to find the GCF, we're going to make a birthday cake for a given number using only prime factors. So the way to start out doing this is to make a small list of prime numbers for reference. First number we think of is 1, but 1 is not prime because so, as Three Dog Night tell us, 1 is the loneliest number. He is not prime and he is not composite. He is special by himself. So as we do this birthday cake method, we're going to look each time to coming up to a number 1, which we call is our birthday candle. We build the cake until we get to a 1. So here in our example, after I've listed 5 primes, 2, which is 3, the first prime, 2, 3, 5, 7, 11. First 5 prime numbers. Those are just to give me a reference point when I build the layers to my cake. Down here where 24 is, you see, I have the beginning, the first layer of my cake. I can choose any prime number that I can think of to start my cake with that is a factor of 24. I could have used 3, but in this case I chose a 2. 2 goes into 24, yes, 12 times. 12 is not yet a number 1 birthday candle, so I keep going and make another layer to my cake. What's another prime that goes into 12? I'll try a 2 again. 2 goes into 12, 6. Still not at my candle. What's a prime that goes into 6? I think I'll try another 2. 2 goes into 6 3 times. Still not at that candle. What's a prime that goes into 3? That is 3. That gets me my candle. I know I have done a prime factorization now for 24, and that factorization is 1, 2, another 2, another 2, times a 3. I got those from 1, 2, 3 2's and a 3. Let's check it. 2 times 2 is 4, times 2 is 8, times 3, in fact, is 24. That is a birthday cake factorization using prime numbers for the number 24. You can try it now using 12 as an example. Pause your video here and try and do a birthday cake factorization. You keep adding layers until you get to that number 1, that birthday candle. All right, now we're going to take what we learned about the birthday cake factorization, combine it with two numbers, a 12 and a 24, and using a Venn diagram, we're going to find our GCF. What you see here is as you remember from just doing, you have a birthday cake factorization for the 12. And on this side, we have a birthday cake factorization for the 24. To start with the 12, you look and see what factors are in common to both 12 and 24. You see those are circled in green. It's a 3, a 2, and a 2, a 3, a 2, and a 2. The factors that are both in common, the prime factors that are in common between 12 and 24, get put in the center, in the green zone of this Venn diagram. The red circle being all the factors of 12, as you can see here. And in the blue circle, we have all the factors of 24. So you can see, for the red, I have a 2, a 2, and a 3, a 2, a 2, and a 3, and I have no other factors left other than the 1 that would go here for 12. So 2 times 2 is 4, times 3, in fact, is 12. 12 equals 12, check. Now when I look at the same for 24, what I see is the common factors are, again, a 3, a 2, and a 2, which are in the center and represent, we already know, the number 12. The one factor that has been left out that is not in common with 12 is 2. So I put that factor in the outside of the green common area, but still within the blue circle. So if I check this, I know I have a 12 here times 2 is a 24, check. So that is one more way. The area in the green, the factors combined, multiplied together, is another way of finding a GCF. That is, we've learned in review 3 ways: listing or the rainbow method. We've learned doing a factor tree, and then we've also learned the birthday cake method. So I hope you've enjoyed today's lesson. Thank you, and this is the end.